In this lesson, we are going to go over function symmetry and classification. So our objectives are to understand symmetry with respect to the x-axis, the y-axis, and the origin, and then we're going to learn to classify functions as even, odd, or neither. So getting started with symmetry, and this is a good visual using certain ordered pairs, okay? If we have symmetry with respect to the x-axis, that means that we could fold this graph along the x-axis and both sides would coincide. Notice how a point, or you could even extend this to a function, that if we take this point 2, 3, the point that is symmetric with respect to the x-axis is 2, negative 3. These have the same x values but opposite y values. Okay. If we look at symmetry with respect to the y-axis, so again, let's say we have this point 2, negative 3. If we were to fold this along the y-axis, both sides would coincide. Okay, so if we have 2, negative 3, we have the point negative 2, negative 3 that is symmetric with respect to the y-axis. And notice how these have opposite x values but same y values. And then the last type of symmetry we have is with respect to the origin. Okay, so notice again, using the point 2, negative 3, with respect to the origin is opposite x and y value. What's happening here is if we draw a line, if we were to rotate this point about the origin 180 degrees, so half a circle, gives us symmetry with respect to the origin. Okay, so in this case, we have the opposite x value, so negative 2, and the opposite y value, positive 3. Okay, so when we're talking about symmetry with respect to the origin, we need to rotate it 180 degrees and see if it still looks the same. So that's a visual on symmetry. Okay, so example 1. So we're going to plot the point 4, 1, and then plot the point that is symmetric to 4, 1 with respect to the x-axis, the y-axis, and the origin. So you can do this visually, or you can use what we just talked about, that if a point is symmetric with respect to the x-axis, it has the same x but opposite y. So we'll go through all of those. Okay, so for part A, or actually, we need to plot 4, 1 first. So that's 4x, 1. So here's my point 4, 1. Okay, and I'm going to draw it bigger just so that we can see it, and maybe I'll zoom in a little bit too. Okay, so x-axis, I'm going to do that in green. So one way you can do this is to visualize where it would end up. So if you were to fold this graph along the x-axis, where would the point end up? If you fold it, it would end up right here. Okay, you can also do this by remembering that symmetry about the x-axis has the same x value but opposite y value. So your point should be at 4, negative 1, which it is. Okay. We will start the other way with y-axis symmetry. So points that are symmetric with respect to the y-axis have opposite x values but the same y value. So opposite x would be negative 4, same y would be positive 1. So negative 4, 2, 3, 4, positive 1. Okay. So the blue dot is my point that is symmetric to 4, 1 with respect to the y-axis, and then with respect to the origin. So again, you can do this visually, meaning if you rotate this point 180 degrees about the origin, that's where our other point is going to end up, or you could remember that it's opposite x, opposite y. And again, here's my line, 180 degrees, puts it right there at that purple point. Example 2a, so you'll be given a graph of a relation, it may or may not be a function, and you'll be asked to determine visually whether the graph is symmetric with respect to the x-axis, y-axis, origin, or it could be neither. Okay, so let's check. X-axis, okay, so if you were to fold this along the x-axis, would we have a graph that coincides? And the answer is no. So it's not symmetric with respect to the x-axis. Okay, with the y-axis, if we fold the graph along this green line, would both sides coincide? The answer is yes. Okay, and with the origin, if we were to take this graph and rotate it 180 degrees about the origin, would we get the same graph? If we were to rotate this 180 degrees about the origin, we would end up with something like this, okay, which we don't have anything there. So this one is only symmetric with respect to the y-axis. Okay. 2b, determine visually whether each graph is symmetric with respect to the x-axis, y-axis, origin, or it could be neither. So again, with the x-axis, we would fold our graph along the x-axis and see if both sides would coincide. And then for instance 2, you could pick a point. There's a point here. If this were symmetric with respect to the x-axis, there should also be a point here, and there's not. Okay. Y-axis, we fold our graph along the y-axis and see if both sides coincide. It doesn't. Again, you could pick a point here. If there was a point there, there should also be a point over here, and there's not. So this is not symmetric with respect to the y-axis. Okay, with respect to the origin, I'm going to erase some of this just so that it's a little bit clear. We are looking to see if we rotate this graph 180 degrees about the origin, if it would still look the same. So if we rotate this 180 degrees, we would end up here. We would have this tail over here, so they do correspond. Okay, and again, what we can do is we can pick a point. Let's use the one we've been using. Okay, so there should be a point with the negative x, negative y value, and there is right here. So this is symmetric with respect to the origin. Okay. 2c, determine visually whether each graph is symmetric with respect to the x-axis, y-axis, or the origin. So x-axis, if we fold this graph along the x-axis, do both sides look the same? Yes, it would coincide. Y-axis, if we folded our graph along the y-axis, do both sides look the same or do they coincide? Yes. Origin, if we rotated this graph 180 degrees about the origin, does it look the same? Okay, so if we rotated it, so picture in your head, if we rotated this 90 degrees, it would be here, and then 180 would end up back at this spot. Okay, you can do that with other points as well, but there's a point here and a corresponding point here. Okay, so this is symmetric about the origin as well. So this has symmetry with respect to the x-axis, the y-axis, and the origin. Example 2d, determine visually whether each graph is symmetric with respect to the x-axis, y-axis, or origin. Again, x-axis, if we fold it in half, does what's above and below the x-axis coincide? No. Y-axis, if we fold this graph along the y-axis, is what's on the right and what's on the left, do they coincide? No. And the origin, if we were to rotate this graph 180 degrees about the origin, this would be something like this, so the answer would be no. Okay, so this would be none, or none of these. Example 2e, determine visually whether each graph is symmetric with respect to the x-axis, y-axis, or the origin. So x-axis, we would fold this graph along the x-axis and see if what's above and below coincide. No. Y-axis, we would fold this graph along the y-axis and see what's on the right and the left to see if it coincides. No. With the origin, we would see if we took this graph and rotated at 180 degrees, rotated at half circle about the origin, would it coincide? Okay, so this would go here, this part would end up here, and it would look the same. Okay, same thing if you rotated. This is going to get too messy, so scratch that thought. Okay, the other thing is just looking at the points. If there's a point here, there should be a corresponding point. So this is 2, 2. There should be a corresponding point at -2, -2. Okay, so this is symmetric with respect to the origin only. Okay, so symmetry. So we just talked about determining symmetry visually. There's also a way to determine symmetry algebraically, and here are the tests to do that. So if a function is symmetric with respect to the x-axis, then you replace y with -y in the formula for the relation of the function, and if you get the same as the original, then it's symmetric with respect to the x-axis. Symmetry with respect to the y-axis, so you take your formula and you replace x with -x, and if you get the same as the original, then it is symmetric with respect to the y-axis. And for the origin, if you replace x with -x and y with -y, you get the same as the original. And remember, these are the things that we just tested. X-axis symmetry means the x is the same, but they have opposite y values, y with -y, okay, and so on. So the first one, example 1, without graphing, determine whether the function is symmetric with respect to the x-axis, y-axis, the origin, or none of these. So first with x-axis, we replace y with negative y. Okay, so we only have one y here, so that's going to become negative y, and everything else stays the same. Okay, so if we solve this for y, we would divide everything by negative 1. And this is to check to see if we get the same. And it's not, okay? So we started off with y equals negative 8x cubed plus x. When we replace y with negative y, we got y equals 8x cubed minus x. It's not the same, so it's not symmetric with respect to the x-axis. Okay. Next, let's try y-axis. So this is where we replace x with negative x. Okay, so y now is going to just stay as y, and we replace x with negative x. And I highly recommend keeping everything in parentheses. And then we simplify, so we get y is equal to negative x cubed is negative x cubed. So this is negative 8 times negative x cubed. And then we just have minus x. Okay, this gives us y is equal to 8x cubed minus x. Okay, still not the same. And then lastly, we have to check the origin. And here's our relation. Okay, so we're going to replace y with negative y and x with negative x. So y with negative y is negative y equals, that should be a negative, negative 8, and then we're replacing x with negative x as well. Okay, and then we simplify and solve for y. So we have negative y is equal to negative 8, negative x raised to the third power is negative x cubed minus x, we keep going, negative y is equal to, this is 8x cubed minus x, and then we solve for y. Y is equal to negative 8x cubed plus x, and it is the same as the original, so this is symmetric with respect to the origin. Okay, so that's the algebra test that we did. Example 2, without graphing, determine whether the function is symmetric with respect to the x-axis, y-axis, the origin, or none of these. So again, x-axis, we take y and replace it with negative y. So we would have negative y is equal to 4x squared. Solve for y to compare it to the original. Oops, that should be negative 1. And we would have y is equal to negative 4x squared. Okay. It's not the same as the original. The original is y is equal to positive 4x squared, so it's not symmetric with respect to the x-axis. For symmetry with respect to the y-axis, we take x and we replace it with negative x. So that is y is equal to 4 negative x squared. Okay, negative x squared means negative x times negative x, which is positive x squared. So this gives us y is equal to 4x squared. It is the same as the original, so this is symmetric with respect to the x, or with respect to the y-axis. Okay. And then lastly, we check with respect to the origin, where we replace y with negative y and x with negative x. Okay, so we have negative y is equal to 4 times negative x squared. Negative y is equal to, we already determined that negative x squared is positive x squared. And if we solve for y, we would get y is equal to negative 4x squared, not the same as the original. So this one is symmetric with respect to the y-axis. Example 3, without graphing, determine whether the function is symmetric with respect to the x-axis, y-axis, the origin, or none of these. Okay, so x-axis, we replace y with negative y. So we get negative y is equal to 3x plus 1. Solve for y to compare it to the original. And this would give us y is equal to negative 3x minus 1. Compared to the original, it's not the same, so this is not symmetric with respect to the x-axis. For symmetry with respect to the y-axis, we take every x and replace it with negative x. Okay, so that gives us y is equal to 3 times negative x plus 1. If we simplify, we get y is equal to negative 3x plus 1. Compare it to the original, not the same. Okay, and then on the origin, let me see, I can probably do it over here. Origin, we take x and replace it with negative x, and y replace it with negative y. So this gives us negative y is equal to 3 times negative x plus 1. So we simplify everything and we solve for y. So we have negative y is equal to negative 3x plus 1. Solve for y by dividing both sides by negative 1. And we have y is equal to 3x minus 1. Compare it to the original, not the same, so this is symmetric with respect to none of these. Okay. The last topic is function classification. So we can classify function as even or odd. So a function is even if it has y-axis symmetry. So on the functions we determined symmetry visually on, or even the ones that we found that had y-axis symmetry, we can call those functions even functions. Okay, and the way that will look is f of x is equal to f of negative x. So what we do is we find f of negative x, which means we replace every x with negative x and see if we get the same as the original. Okay. Odd means that the function is symmetric about the origin. So again, with the functions that we determined origin symmetry visually or by replacing y with negative y and x with negative x, you can also classify those as odd functions as long as they're functions. Okay. So what we do is we still find f of negative x. That means we replace every x with f of negative x, and we compare it to negative f of x. Okay, and I'll show you what that looks like as we go through the examples. And then just a note, if f is not 0, then a function cannot be both even and odd. So what that means is if you find a function is even, you can stop there. You don't have to see if it's odd. It can't be. So example 1, determine whether f is even, odd, or neither. Okay, so to first check to see if the function is even, we check f of negative x. Okay, so that means that our input, we're replacing every x with negative x. Okay, so that looks like negative x to the 4th minus 3 negative x squared plus 9. Okay, so this equals negative x to the 4th is positive x to the 4th. Okay, negative x squared is positive x squared plus 9. We compare it to the original, okay, because if a function is even, f of x is equal to f of negative x, which is saying the original is equal to f of negative x. And in this case, it's the same, so this function is even. And remember that note at the bottom of the previous slide, if a function is even, you don't have to check if it's odd because it can't be both. Okay. Example 2, decide whether f is even, odd, or neither. Okay, so let's first, for both, remember a function is even if f of x is equal to f of negative x. And it's odd if negative f of x is equal to f of negative x. So for both of these tests, you're finding f of negative x. Okay. So f of negative x is equal to negative x to the 27th power. You could write this out 27 times, but since it's an odd power, okay, we're going to end up with a negative x to the 27th. Okay, so in this case, it doesn't equal f of x. So this function is not even. And now what we have to check is negative f of x. Okay, so this is like putting a negative sign in front of the whole right-hand side of the function formula. Okay, or negative, negative, okay, which is x to the negative 27th. And now we compare. So negative f of x is equal to negative x to the 27th. And f of negative x is also equal to negative x to the 27th. These are the same, so this function is odd. Last example, decide whether f is even, odd, or neither. Okay, so again, both tests require us to find f of negative x. So we replace every x with negative x. Okay, so this gives us 2x to the 4th. Negative 3 times negative x is positive 3. So this is not, it does not equal f of x. Okay, so this function is not even. And then we need to find negative f of x, okay, which is negative 2x to the 4th minus 3x. And we simplify. Negative 2x to the 4th plus 3x, okay? And then we look to see if it's the same as f of negative x. So let me draw it over here. So negative f of x is equal to negative 2x to the 4th plus 3x. F of negative x is 2x to the 4th plus 3. Oops, that should have been an x there. Okay. And these are not the same, so this one is neither. It's not even or it's not odd, it's neither. Okay. Thank you for watching. If you have any questions, feel free to reach out to me.